Hi, welcome back to Moose and Chemistry. We're going to do a VSEPR model lesson 3 today. So we're going to take a couple of ions. So let's try NO3 first. That has a -1 charge. So now nitrogen, remember, has 5 valence electrons. Because it comes in group 15, you can get rid of the 1. Oxygen has a total of 6 valence electrons. So it comes in group 16, so we just get rid of the one that tells us we have 6 valence electrons. Now remember that there's a -1 here, so that's going to come into play a little bit later. So now, let's take a look at this. We're going to go and we're going to add up all our valence electrons. So we have 1 N with 5 valence electrons. And we have 3 O's, each with 6 valence electrons. This gives me a total of 18 valence electrons and 5 valence electrons. That gives me a total of 23 valence electrons. But remember that we had that -1 charge right here? Well, that -1 charge is going to add 1 valence electron. So that gives us a total of 24 valence electrons. So whatever structure we draw has to have 24 valence electrons. So let me go ahead and erase that right there real quickly. All right, so back to this. So now what we do is we're going to go ahead and set up our nitrogens, and we're going to put O's around it, like so. So we got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now, you think the structure might look right, but there's a problem. Nitrogen has to have an octet. That means it has to have 8 valence electrons. But right now we're only seeing 6. So we're going to have to make this right. So let's go ahead and erase all this. So what we're going to do is we're going to actually take 2 valence electrons from this oxygen right here. We can take it from any oxygen we want to, but I'm just going to choose those 2. And let's go ahead and erase those valence electrons. And we're going to put a bond right here. So now, nitrogen now has its octet, and each of these oxygens have their octets, and we still have a total of 24 electrons. So let's check to see if the structure is the best possible structure. So we're going to use formal charge, remember? Formal charge of nitrogen first. So remember that formal charge is valence electrons minus non-bonding electrons minus bonding electron pairs. So this gives me 5 valence electrons coming in, non-bonding electrons 0, and bonding pairs we have 4, which gives us an overall charge of 1. So although we would like to have it as 0, but maybe this is not such a bad drawing. So let's do the formal charge of oxygen. So we're going to take this oxygen first here. And we're going to go, okay, oxygen came in with 6 valence electrons. It has 4 non-bonding electrons, which are right here and right here. And we have 2 bonding pairs right there. So that's going to give me 0, and that's good. Okay, that's good. So let me go ahead and erase these marks here real quickly. So we know that oxygen looks okay. So now let's take a look at one of these other oxygens. So let's look at this oxygen here. We could have used that one here, but it doesn't really matter. So we're going to use that oxygen. So we're going to do formal charge, and we're going to call this oxygen 1, in this case, or oxygen prime. Oxygen comes in with 6 valence electrons minus 6 non-bonding electrons, because you got 2 here, and 2 there. Minus 1 bonding pair, which you have there. This gives us a -1 charge. Okay, so this is looking okay so far. So let me get this -1 charge here. So let me erase these other marks here real quick. But I want you to notice something. That this oxygen right here is the same as that oxygen right there. So in essence we have 2 minuses because both those oxygens are the same. So we have a plus here. So this would be like 1 minus 2, which would be equal to -1, which is our -1 charge right there. So this is looking okay. So we're still doing all right. So now what we're going to do is, to finish this, we're going to put it into a radical that looks like this. And we're going to go nitrogen, because we want to spread out the charges, because electrons don't like each other. So spread the bonds apart. But you know what? Who's to say that this is the only correct structure? There's something called a resonance structure. So let's go ahead and erase all of this right here real quickly. Again, I wish I had a bigger eraser. Maybe Linza will think about that next time when they do some updates. So let me go ahead and erase all this real quickly, because I'm going to probably need the space. We're just erasing. It's having so much fun here erasing, huh? You probably do a lot of erasing at home yourself. All right, so now let's get back to this here real quickly. So the structure could also look like this. And that's where the double bond can be. And of course, we place our electrons around it. Again, we would write that 1 minus, or nitrogen can actually have a charge, double bond here. And that's how you do nitrate ion. So let's look at another one. So I'm going to go ahead and clear all the drawings. And we're going to look at another compound. The next compound we're going to look at is going to be CO3, and that has a -2 charge. So now we know that carbon has 4 valence electrons because it comes from group 14. Get rid of that 1 there. Oxygen comes from group 16, so we're going to have 6 valence electrons. So carbon is our least electronegativity, and also it has 4 opening docking ports, 4 electrons that could be bonded with. So what we want to do now is we want to figure out how many valence electrons we have here. So carbon comes in with 4 valence electrons, and each oxygen, we have 3 of them, comes in with 6 valence electrons. This gives us a total of 18 electrons for oxygen and 4 electrons for carbon. So that gives me 22 electrons. But look here, we have a -2 charge. So we have to add 2 electrons to give us a total of 24 electrons. All right, so now we want to put, again, like the last one, put carbon. And this time I'm going to be a little bit smarter about it. I'm just going to put a 0 there, a 0 there, and a 0 there. So we're going to bond 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. This looks okay except for one problem. Carbon needs an octet. So how are we going to make an octet for carbon? Well, what we're going to do is we're going to take 2 electrons from right here. I could have taken them from anywhere, but I just chose those. So I make that a double bond. Now, we still have 24 electrons, and now carbon has an octet also. So let's see if this is the best possible structure. Again, we can use something called formal charge, which equals valence electrons minus bonding, non-bonding electrons, minus bonding electrons. Okay, so the formal charge for carbon would be, carbon comes in with 4 valence electrons, 0 non-bonding electrons, if we look at the center of that, and we have 4 bonding pairs. That gives us 0. Okay, that's a great start. So now we have 2 different oxygens, so we have to do each of the difference in oxygen. So we'll call this oxygen 1 for argument's sake. So oxygen 1 came in with 6 valence electrons minus 4 non-bonding electrons minus 2 bonding pairs. And that looks great also. Let's look at this one. We'll call that one oxygen 2. We could have used the other one, but it doesn't really matter. So the formal charge of oxygen 2 is going to be 6 valence electrons came in. We have 6 non-bonding electrons and 1 bonding pair. That gives us -1. So this one has a -1 charge. So this one also would have a -1 charge because it looks exactly the same. Now, so we know that this is the best possible structure. So now let's go ahead and, oh, look, you have a double bond here, but why can't it be here or there? So we have a resonating structure, so we're going to draw 3 versions of this. So I'm going to go ahead and set my radicals up. So I'm going to put C, and I'm going to put the first one in here because the one we just did. I love doing these. They're so much fun. I hope you're having a lot of fun too, like I am. Because this is actually kind of cool to try to figure this out. Almost there. All right. So now we're going to put a -2 charge on each of these. And that is your carbonate ion. Okay, now, there's one more I'd like to do. So let's clear all the drawings. I know this video is going to be a little bit longer than most of mine, but that's okay. All right, so now, stay with me on it. We're going to do NH4. This time we're going to have a plus sign. So we're going to do something a little bit different on this one. So nitrogen comes in with 5 valence electrons because it's from group 15. Hydrogen comes in from group 1. We're not going to cross out that one because we need that 1 electron. So now let's figure out the number of valence electrons. So we have 1 nitrogen and 5 valence electrons. We have 4 hydrogens with 1 valence electron at each. So this gives me 4 valence electrons. 5 valence electrons gives me a total of 8 electrons. But notice that this is a plus sign. In the last 2 that we did, it was a minus sign. So what we're going to do, instead of adding an electron, we're going to subtract an electron. So we're going to go -1 electron. Sorry, I can't add. You know, I just saw that I can't add. Hang on for a second. 5 and 4 is not 8. 5 and 4 is 9. Silly me. So this is going to give me a total of 8 electrons. I was really thinking about taking that electron out. Yeah, I know, that's a good cover, huh? So what we're going to do is we're going to draw our nitrogen, and we're going to put our hydrogens around it, like this. So we've got 2, 4, 6, 8. All right, now let's see if this is the best possible structure. So we're going to use, again, formal charge for nitrogen. Remember that it's valence electrons minus non-bonding electrons minus bonding electron pairs, right? So nitrogen came in with 5 valence electrons. It has 0 non-bonding electrons, and our bonding pairs is 4. So that gives us a total of a +1, which is good in this case, I guess, because we have a charged atom. So let's look at the formal charge of one of the hydrogens. We don't need to do all 4 of them. Just one of them will do. So we had 1 valence electron hydrogen. They're all being used, so there's no non-bonding electrons. It's 1 bonding pair that gives us 0. So this is 0, this is 0, that's 0, that's 0, that's +1, which makes sense. So this becomes a radical, and we have N, H, 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 plus charge. Now, this would become an AX4, which we call a tetrahedral. Now, I was so busy solving the other ones, I forgot to tell you that a N, like the NO3 one, remember that NO3, let's clear these drawings real quickly, and let's go back and fix that. Let's cancel that for a second. And the bond angles, of course, are 109.5 degrees. All right. So that means the bond angle from here to here is 109.5 degrees. Now, looking back at, of course, we have to go back and do something here real quickly. So clear all drawings here. The CO3, -2, we said looked like this. And it had a 2- charge. And notice that this is A, this is X, this is X, this is X. This is called AX3, which we call a trigonal planar. And its bond angles are 120 degrees. And again, I forgot to do that when I was doing this other thing because I was so excited about balancing stuff. And so let's look at the other one, the nitrate ion, the NO3 with the -1 charge. Again, that looked like this. And again, remember these are resonating structures, so it doesn't, we could have done all three of them, but I'm not going to do that because you've seen that earlier. And this is a -1 charge. So this is A, X, X, and X. Again, this is an AX3 trigonal planar. And again, the bond angles are 120 degrees. Well, what an awesome lesson, and you guys have an awesome day, and I can't wait to see you again on our next VSEPR models at mooseandchemistry.com.